review of a couple important concepts for entropy. First of all, as entropy goes up, disorder goes up. So we need to remember that the more positive your entropy value, the more disordered or disorganized your substance is. Additionally, we need to remember that entropy or disorder is often directly related to movement. So at a molecular level, solids are the most ordered. They do move at a molecular or atomic level, but they don't move very much. So I think of them like this. Whereas liquids, they move a little bit more. They're a little bit more disordered. And gases are like this. All over the place. So gases are the most highly disordered, disorganized, and highest in entropy. A couple of other principles we need to remember is that entropy can never be negative. It can only be zero if you go all the way down to 0 kelvins, which is negative 273.15 degrees Celsius. So very, very cold. You go all the way down to that temperature, you're now cold enough that entropy is equal to 0. There is, of course, a difference between entropy, which we label as S, and delta S, that is difference in entropy or change in entropy. So delta S is the difference in the total S values of products versus reactants for any chemical reaction or physical change. So again, delta S is a change in S. So basically what I do is I take all of my S values for my products, add them all together, all of my individual S values for my reactants, add them together, and I subtract the reactants from the products. That's a delta S. It's the difference in S values. Delta S can be negative because you can have your S values of your products be less than or greater than that of your reactant. So S or delta S can be negative, it can be positive, it can even sometimes be equal to 0. But S, that's an individual entropy value for an individual substance, so each reactant or each product. It can never be negative, ever, and it can only be 0 if you're plunging all the way down to the super cold temperature. Does that distinction make sense? Okay, good. With all of that background laid out, let's take a look at our question. It says that as water cools slowly from gas all the way down to freezing, what happens to its entropy? Well, let's think about that. Our water here is starting as a gas, so it's really, really going like this, and then it gradually gets cool, so it turns into a liquid. So it's doing this as a liquid, and then it gets colder and colder and colder until it eventually locks and becomes a solid, so it's frozen now, okay? So we went from really high entropy to medium entropy all the way down to very low entropy. At no point is the entropy ever going to be a negative number, okay? And it's only going to be 0 ever if we go all the way down to solid and then plunge it all the way down to 0 kelvins, okay? So with that information in mind, let's see if we can cross off some of our multiple choice options here and end up focusing on whichever one is correct. Option A suggests that the entropy is going to become more positive. Well, that doesn't make sense because as you go from gas down to liquid, down to solid, you're actually becoming less positive. You're not going to become negative, you're just going to become less positive. So we can cross off option A. Option B says that it becomes negative. Well, as I just pointed out, that is not going to be true ever for any S value ever. Option D says that it becomes 0. Now that will only happen if we plunge our solid water all the way down to 0 kelvins, and the question hasn't specifically told us that that is what is occurring. So we can cross off option D. Option E says that it becomes a larger negative number. That also doesn't make any sense because the entropy value is not going to be negative ever. Okay? Now remember, delta S can be negative, but S without the delta in front of it can never be negative. Okay? That focuses us in on option C, which says that it becomes a smaller but still positive number. Does that make sense? Yeah, it does. So S values will always be positive, but they're just going to get less and less positive or smaller as we go from gas to liquid to solid. Thus, this question's correct answer is option C.